Hey everyone, so this is graphing quadratics in factored form. So this is just similar to the lesson we did on Tuesday. So I want you to pause the video and try the do now. Again, we gotta practice those SAT questions. All right, so we have a partially filled pool contains 600 gallons of water. All right, so we got a pool. And then a hose is flowing into the pool at 8 gallons per minute. How many gallons of water will be in the pool after 70 minutes? So pretty straightforward. 8 per minute times 70 minutes, that's 560. And then we have to add the starting amount, so 1160. And that's it. And this is a grid in. Okay, so just like before, I want you to start with finding the vertex pre-factored, right? So pause and try this. So our formula is negative b over 2a. So that's negative 2 over 2 times 1, negative 1. So our x value is negative 1. To find our y value, we plug in. So negative 1 squared, 2 times negative 1 minus 8. So that's 1 minus 2 minus 8 is negative 9. And then factor and solve. So this is an MC chart. Right? X squared plus 2x minus 8 equals 0. So what multiplies to negative 8 combines to 2? Just 4 and 2. So x plus 4, x minus 2 equals 0. So then to solve, we set each of those equal to 0. X is negative 4. X is 2. So those are our roots. So negative 4, 0, and 2, 0. Our y-intercept is, what do you get when you plug in 0? Negative 8. Symmetric point, we double the x. We got negative 1 as the x value of our vertex, double it. And then our y-intercept, and it's the y-intercept. So we got negative 1, negative 9. 0, negative 8. Negative 2, negative 8. 2, 0. Negative 4, 0. And that is the saddest parabola I've ever graphed. Oh well. It's like that was better. I don't know. Some days you're really good at it. Some days you're just not. All right, so remember, if it was in factored form, how would we find the vertex? What can I do with those two numbers? If I add them and divide by 2, you get that negative 1. So if it's already factored, we find the average of the roots. The average of the roots. The average of the roots. Okay, so pause and try this one on your own. It is going to be a 0.5. That's okay. Oh, no, it's not going to be 0.5. This will be a nice number. All right, so we start by setting each of those equal to 0. We get x equals negative 5 and x equals 11 for our roots. And then to find the vertex, we're going to add those, divide by 2. 11 plus negative 5 divided by 2. 6 divided by 2 is 3. Now how do you find the y value? We plug into the equation. So 3 plus 5 times 3 minus 11. That's 8 times negative 8, negative 64. How do we find the y-intercept? Well, that's a 0. It's the exact same way we find the vertex. We're going to plug in. This time I'm plugging in 0, though. So 0 plus 5, 0 minus 11, that gives us negative 55. Symmetric point, double the vertex, so 6. And then the y-intercept. So let's start with this graph. So I need to go down to negative 64. I need negative 55. I need 11. Negative 5. And I try to make it sort of as close as I can to like accurate. Let's see, 6 is going to be around there. You know, we're not going to be perfect, but... Oh, wait, I need 3 also. Alright, so 3, negative 64. So there's my parabola. Okay, what is the domain? Domain, all real numbers. Remember, or a lot of us like to write negative infinity to infinity. Domain is left comma right. On this graph, the farthest thing to the left is an arrow. Farthest thing to the right is an arrow. So that's, and remember, x is on the left or negative, so negative infinity, infinity. And then the range, that's domain. And then range is the lowest, comma, highest. The lowest point on this graph is right here. That's a y value of negative 64. And then the highest value is an arrow, so that's infinity. Or you could just say y has to be greater than or equal to negative 64. Okay. So this is a little harder than the other day, so pause and try this on your own. So we have negative 1/2 x equals 0 and x minus 6 equals 0. So this is 6. This is just 0. Because if you divide, 0 divided by anything is just 0. So 0 and 6. 0 and 6. And then what's the average of 0 and 6? That's just 3. Plug in 3. Negative 1/2 times 3 minus 6. This is going to be a decimal. 4.5. Y-intercept. Where does this cross the y-axis? If you plug in 0, you get 0, 0. Symmetric point. Double. It's the same thing. It's whenever you have a 0 as one of the roots, the symmetric point and y-intercept are the same as the roots. All right, so 3, 4.5. So we don't have a lot of points here. That's okay. Domain. Again, negative infinity to infinity with every parabola. Range. The lowest thing on here is an arrow, so negative infinity. And then the highest point is that y value, 4.5. Make sure you put a bracket there, because a bracket means it can be equal to it. All right. Try this one. Pause, do it on your own. All right, so my roots are negative 3, 0 and 10, 0. Again, we set each of those equal to 0. And you can just ignore the 2. The 2 doesn't do anything for the roots. And then to find the vertex, we're going to find the average of the roots. So, I don't know, a lot of space on this one. 10 plus negative 3 divided by 2. 7 over 2, which is 3.5. Now make sure when you plug in 3.5, you plug in that 2 also. So 2, 3.5 plus 3, 3.5 minus 10. I got negative 84.5. And then to get our y-intercept, plug in 0. So 2, 0 plus 3, 0 minus 10. Don't forget that 2. You get negative 60. So 0, negative 60, double the vertex, 3.5 doubled is 7, negative 60, negative infinity to infinity. Okay, let's see. I have to go down to negative 85. Let's call that, because negative 84.5. I'll put 60 here. I need to go over to 10, negative 3. Let's see, we need 3.5 which is like here, and say 7 would be like here. All right, so 3.5. And then I don't know if I've really been doing this, but you should really label 100% the vertex, 3.5, comma, negative 84.5. When we have points just out in the middle of nowhere, make sure you label it. And then the range, the lowest point is negative 84.5. The highest point is an arrow, so infinity. All right, little different. This is not factored, so just figure out what is what. If we try to do negative b over 2a, what do we get? There's no b value, so it's just 0. So my vertex is 0, negative 7. X squared minus 7 equals 0. How do we solve that? Well, the easy way is we add 7 both sides. X squared equals 7. Take the square root. X is plus or minus the square root of 7. So I'm going to put that in decimal form because that's not helpful. 2.646. My y-intercept is exactly the same as my vertex, which means there's no symmetric point. So to graph this, I'm going to go 0, negative 7, and then my roots. So 2.6, negative 2.6. That's it. Like, there's not a lot to do with these, especially when you have the vertex has a 0 as the x value. Domain, negative infinity to infinity, and then range. What's the range? Lowest comma highest. Lowest is negative 7, highest is an arrow. All right, last one. I'm going to factor this one. You could do negative b over 2a, but I want to factor it. So I notice it's got a GCF of 2x. So I get 2x, x minus 7. So when I set that equal to 0, my roots are 0, 0, and 7, 0. Right? Halfway between 0 and 7 is 3.5. I'm going to plug that into my equation. So 2 times 3.5, 3.5 minus 7. I got negative 24.5. My y-intercept is 0. What do you get when you plug in 0? 0, 0. Again, whenever our symmetric point and whenever you have a GCF, the symmetric point and the roots are the same. So that, because if you double 3.5, you get 7, so 7, 0. Let's make that 7. We got 0. I gotta go down to negative 24.5, 3.5. So that's my 3.5, negative 24.5. And that's my graph. Negative infinity to infinity, lowest, negative 24.5, highest, an arrow. And that's it. All done. All right, have a fabulous day. I will see you later.